Hello! So in this video we're going to go over how to use a model kit to solve problems with stereocenters, Newman projections, and chair conformers. So at my university it was pretty standard to be able to bring in your model kit to your exams in midterms and finals. So to use this to your advantage, you should know how to use them. So the one I'm going to go over with is molecular equations. There's the one that my university is telling us to buy. If you have another one, hopefully you can find this helpful. I'm not affiliated with this company, I'm just doing this for the sake of anyone who needs it. I ended up trading my stuff in and putting them into a Ziploc bag because it's easier to take in and out. Also, just a really simple thing of advice here. Pre-make your molecules before you go into a test. You know there's going to be a chair conformer question, just build them beforehand, like so. Newman projections, maybe just have a 2-carbon one ready to go. Anyways, so just for molecular equations, they're going to give you everything like this. You're going to want to put these two together like that, stick them together, and then pull. You want to hear that snapping sound. There you go, snapping sound. There you go, that's how you know it's in and good to go. Don't put them together unless you hear that snapping sound, especially if you're a chair conformers, because otherwise it's not going to flip correctly. So for a stereocenter, I just use one of these and assume everything to the left or right can be the R groups. We're not going to worry about it. But they give these little balls so you can start marking stuff. So they give you a little key and they tell you that the whites are going to be hydrogens, I believe. Green's usually nitrogen, oxygen's usually red. But for the sake of doing stereocenters, I would make these, they're pretty arbitrary. Just make them what you need to do to help you visualize the molecule. So maybe I'll call this white here a hydrogen. I'll leave this black one here, we'll leave that as a methyl. Maybe I'll make this oxygen, make a alcohol group. Maybe I'll make this an amine group. Put something in there. When you're doing your stereocenters, and you're doing projections, always put your lowest priority substituent in the back. So that's going to be our hydrogen in this case. Then from there you can go to the atomic number. You have nitrogen, you have oxygen and carbon. So it's going to go oxygen to nitrogen to carbon. That'll be your S. So from oxygen to nitrogen to carbon, hydrogen's in the back, so you can do your counting, that will end up being S. Alright, if your H is in the front, same thing happens, but once you have your S, convert it back to an R because your H is in the front. So that's for stereocenters. And then for Newmans projections, I usually just do the carbons I'm looking down. Again, I'll assume everything else can be an R group. Maybe I'll make the red an R group if it's a lot of carbons, if it's something more pressing like a sulfur group or again an alcohol group, I'll put that in again with my reds and whites. Cool thing about these model kits, you can spin them. They do have rotation about their axes because they are sp3 hybridized. You're able to rotate about this. If you want to do this little bonus question here, if it is sp2 with a double bond, which your model kit will offer, but I'm not going to go over it, they will not rotate around the axis, but they can rotate in space together. Anyways, lastly, I want to go over chair conformers. Again, make sure they're all plopped in. So when you do your chair flips, everything works together. The strain will kind of pull them up or down depending on where you're pushing and pulling. So right now, this will be your boat conformer. Your boat conformer, you can kind of see it there. We want the chair conformer, so keep one end up of your boat and put the other one down. To check that you have your chair conformer, you should have 3 axial above the plane, 1, 2, 3. And 3 axial below the plane, 1, 2, 3, and then that'll make all the rest of the equatorial the same. To label them, again, use your little balls here. So I'll put we'll call this a hydrogen up here in the axial position, and we'll make this red a methyl group in our equatorial. So in space, just because molecules the way they behave, this is constantly going back and forth all the time, and depending on what state they'll be in is how much energy it costs. So the least energetic, the one that costs the least amount of energy, it will spend the most time because it's more stable. I'm going to talk a little bit about the concept here. Things in the equatorial state should be your larger groups. Things in the axial state should be your smaller groups. So out of this molecule, having a hydrogen equatorial and having your methyl group in the axial is more costly, so it's not going to hang out in this chair conformation. No, remember, no bonds are broken. It's just going to do a chair flip. All your axials become equatorial, all your equatorial become axials, Up stays up, down stays down. So now we have our methyl group in the equatorial and our hydrogen in the axial. This is the more stable of the molecule, so as it's rotating back in space, it's going to spend more time here. The exact number, I didn't calculate it, you can go look it up yourself if you want, but just want to be able to let people know how to do these chair flips. If you have any questions, feel free to leave a comment below. I'll try to get to it as soon as I can. If there's a video or concept you're struggling with, please let me know in the comments below. Thank you, have a good one.